Probability and predictions. You can solve predictions using a proportion. So your probability is the event over the total, and you can have your prediction over the new total. All right, so let's take a look at our first example. If you roll a number cube 30 times, how many times do you expect to roll a number greater than 2? So we're going to take the probability of greater than 2. So on a number cube, you have 1, 2, 3, 4, 5, and 6. 3, 4, 5, and 6 are greater than 2. So the probability of greater than 2 is 4 out of 6. So you can say 4 out of 6 equals x out of my new 30 times. If you want, you can simplify 4, 6 first before solving this proportion. You can either use the cross product rule or you can do equivalent fractions. 6 times 5 is 30, so 4 times 5 is 20. We are expecting 20 times for it to be greater than 2 out of a total of 30. The answer is 20. Okay, if you roll a number cube 30 times, how many times do you expect to roll a number greater than 3? So same example, probability of greater than 3. Your options are 1, 2, 3, 4, 5, and 6. 4 is greater than 3, 5 is greater than 3, and 6 is greater than 3. So you have 3 out of 6, and we're predicting it to do it out of 30 times. You can either simplify 3, 6 first before you solve it, or either way. You could do the cross product rule, 3 times 30, get an answer and divide by 6, or you can do equivalent fractions. 6 times 5 is 30, so 3 times 5 is 15. We are expecting 15 times out of 30 for it to be a number greater than 3. All right, if you roll a number cube 60 times, how many times do you expect to roll a prime number? So we want our prime numbers on a number cube. Remember, our options on a number cube are 1, 2, 3, 4, 5, and 6. Our prime numbers are 2, 3, and 5. Remember, 1 is not a prime number because by definition, prime number is a number times itself times 1. It has to have 2 factors. 1 only has 1 factor. Okay, so the probability of prime is 3 out of 6, and we're going to do it for 60 times. If you want, you can simplify this first. You can either do cross product rule or equivalent fractions. 6 times 10 is 60, so 3 times 10 is 30. We're expecting 30 times out of 60 for it to be a prime number. A bag contains 9 red chips, 4 blue chips, and 7 yellow chips. You pick a chip from the bag, record its color, and put the chip back in the bag. If you do this 100 times, how many times do you expect to remove a yellow chip? So we have probability of yellow. So in this bag, I have 7 yellow. Out of 9 plus 4 is 13 plus 7 is 20. And we're predicting to do this now 100 times. So now we can do equivalent fractions or we can do the cross product rule. 20 times 5 is 100, so 7 times 5 is 35. We're expecting 35 of these to be yellow out of a total of 100. A bag contains 6 blue chips, 14 red chips, 9 yellow chips, and 11 orange chips. You pick a chip from the bag, record its color, and put the chip back in the bag. If you do this 200 times, how many times do you expect to not remove a yellow? I want everything that's not a yellow. So not a yellow is blue, red, and orange. So 14 plus 6 is 20. 20 plus 11 is going to get me 31. So I have 31 out of a total of 40. Okay, we're going to do this 200 times. I can't really simplify the diagonal, so we're just going to have to do the cross product rule. So 31 times 200. Bring down your zeros. 2 times 1 is 2. 2 times 3 is 6. So we have 6,200 divided by 40. We can cancel out the 0. 620 divided by 4 goes in there 1 time. Goes in there 5 times. And 5 times. So we have 155 are not yellow out of a total of 200. Okay, if Jenna flips a coin 60 times, how many times would she expect the coin to land on heads? The probability of heads is 1 out of 2, but we're doing this for 60 times. So 60 times 1 is 60. 60 divided by 2 is 30. So we're expecting 30 heads out of a total of 60. Donovan flips a coin a total of 96 times. How many times should he expect the coin to land on tails? The probability of tails is 1/2. We're doing it for 96 times. So 1 times 96 is 96. 96 divided by 2. We can go in there 4 times. And we can go in there 8 times. So we're expecting 48 times out of 96 for it to land on tails. Cameron records the results of the next 50 flips. The results are shown in the table. Based on Cameron's results, if he flips the coin an additional 75 times, about how many times should he expect the coin to land on tails? So our experimental probability is 18 out of 50 flips, but we want to do it for an additional 75. So we can do the cross product rule. 75 times 18. 8 times 5 is 40. 8 times 7 is 56, plus 4 is 60. Put a placeholder. We have 5, 7. Add it up. We have 1,350 divided by 50. We can do a zero trick here and do 135 divided by 5. We can go in there 2 times. And we can go in there 7 times. So we're expecting it to be 27 times on tails out of an additional 75. Lee's history teacher states in the beginning of the year that he randomly gives pop quizzes one day each week. To test his statement, which day of the week a pop quiz is given for 9 weeks. Based on the result, how many times can Lee expect to have a pop quiz in history on a Friday for the remaining 27 weeks of the school? Okay, so we have, on Fridays, we have 4 quizzes are given out of 9 weeks. And we want to know how much are for the remaining 27 weeks. So we can say 9 times 3 is 27. So 4 times 3 is 12.